The Pacific Ocean, an endless source of humid air that precipitates relentlessly when it hits the coast mountains of British Columbia. Drenching winter rains pile snow onto the rugged summits. In the valleys, rain soaks everything, feeding the trees, which grow fast and become some of the tallest on Earth. Ferns and woody shrubs tangle the understory. Wildfires are rare in this wet forest type, and time unfolds slowly. Hidden in the mist-filled valleys is one of the deepest forests on Earth, and it holds mysteries that beg me. Its history, its ecology, the superlative tree. But the forest is layered and complex. It is vast and dynamic, with cycles of life and death unfolding across a myriad of space. But beyond its complexities, the forest is still there for us to enter, to connect with, to study and observe. So we document its ecology and the processes that shape it. We learn about the legacies of our own interventions. And we begin to form a story of the forest and how we must steward it through time. So I studied these forests for 6 years in university, and when I was hired by the University of British Columbia to help study and scientifically inventory their Malcolm Knapp Research Forest, the answers to my questions were becoming closer and closer within reach. We're now right at the edge of the North Alouette River Canyon. This is what the coastal temperate rainforest is all about. Some dead standing trees. Those are important for wildlife. Look at these large stumps left over from the old growth forest trees that would have been 700, 800 years old. So the research forest is just steeped in history. There was a large fire about 80 years ago that swept through the half of the forest, and it was during a period of logging. And one of the great remnants left over from that is these huge red cedar stumps, like this one we've just come across. It's kind of interesting, it's got some steel bolts hammered into it. Just lots of these big giant cedar stumps all around. You can imagine what this red cedar forest would have once been like. In exploring the forest, I began to learn of its past. There was once an ancient ecosystem that developed here, nearly untouched for millennia. But that was suddenly disrupted. The land bears record to an industrial past. We discovered scars left in the landscape by abandoned logging camps, stumps charred by fire, and old machinery left behind in the dust. Our mission was to collect information for the future management and research of the forest, but with each passing day, in each plot that we visited, a more personal connection began to unfold. There was a sense of timelessness, of shared challenges and adventure. Everywhere we went, we were experiencing the landscape as had generations before. About half of present-day Malcolm Knapp was harvested very rapidly in the 1920s, very unsustainably, which eventually contributed to the end of logging in the forest. We get a lot of this forest, same age, about 80 years old, throughout the forest. Today we're doing this plot further up on the mountain, and right now we're arriving at the remains of the old growth forest.
So not very common. Getting up into some of this old growth here, and the first thing you notice is that the trees are just way bigger, much more complex. There's an old cedar tree, probably 700 years old. And then the average tree in here is, just a lot larger than what you see below.
In our inventory of the 5,000 hectare research forest, we were to set out across mountain slopes, canyons, boulder fields, and lake shores. We would traverse along ridges and through deep valleys. We were to experience the forest in its entirety practically by walking to plots distributed across it. Later, we would be able to analyze the data, review it, synthesize new knowledge about how the forest is changing and varied across the landscape. Ahead of us was an incredible opportunity for discovery in an 8-month-long scientific inventory of the UBC Malcolm Knapp Research Forest.